Welcome to this explainer. When we casually look down at the ground, it's super easy to think of rocks as, well, static, dead objects, right? Just this dull, solid stage where the actual exciting drama of biological life plays out. But what if I told you that the ground beneath your feet is absolutely alive with history? In this explainer, we're going to completely reframe how you see the mineral world. Because rocks, they aren't passive bystanders. They are the dynamic protagonists of Earth's story, and they've been co-evolving right alongside biology for over 4 billion years. So here is our epic roadmap for today. We'll be covering Earth's 4.5 billion year story in 5 parts. The primeval mineral hell, life shapes the stones, sculptors of the Earth, humanity's mineral alliance, and finally, our new plastic legacy. Let's get right into it.
Starting right at the very beginning with Part 1, the primeval mineral hell.
You've probably heard the famous saying, "We are all made of stardust." Well, our story begins in a vast cloud of dust and gas in space, and that phrase isn't just some poetic metaphor. It is a profound geological truth. Over 4.5 billion years ago, tiny mineral particles, literal debris from exploded stars, began to clump together through gravity. They went from the size of a fist to a basketball to hundreds of kilometers across. Every single piece of rock out there, and eventually every piece of us, began as these mineral-rich stardust particles drifting in the cosmic void.
Around 4.5 billion years ago, this newly formed Earth was an absolute mineral hell. I mean, just a molten, uninhabitable ball of magma. Gravity pulled heavy metals like iron down to form the planet's core, while the lighter stuff cooled on the surface into dark basalt, making up Earth's very first crust. Then, 4.46 billion years ago, a massive Mars-sized collision blasted debris into space, creating our moon. Back then, it hung in the sky like a second red-hot sun. As the planet finally started to cool, around 4.4 billion years ago, condensing water vapor rained down to form the first oceans. And get this, those oceans were actually green because of massive amounts of dissolved iron. Crazy, right?
Moving right along to Part 2, Life Shapes the Stones. So, in those primordial oceans, a magical combo of water, heat, and minerals finally sparked life. Now, early on, Earth's atmosphere was heavily composed of methane and ammonia with basically 0% oxygen. But then, early photosynthetic bacteria emerged. They started capturing sunlight and producing oxygen as a byproduct. At first, all this oxygen was just absorbed by the ocean and bound right into the rocks. But eventually, the rocks actually filled up. Oxygen flooded the sky, shifting the atmosphere up to 2% oxygen. This great oxygenation event literally changed the planet's chemistry, built the protective ozone layer, and paved the way for more complex life.
And as complex life evolved, some tiny marine wanderers learned an incredibly cool trick. Enter the coccolithophores. These are a specific type of microscopic marine phytoplankton. These single-celled organisms figured out how to use the minerals floating around them to build tiny protective plates out of calcium carbonate. They were essentially creating microscopic organic stones to wear as armor.
To really wrap your head around the sheer scale of their impact, think about this. There are between 10 and 100 billion of these plankton in a single liter of seawater. And when they die, those tiny calcium plates just sink to the ocean floor. It sounds totally insignificant, right? Just a dusting. But those skeletons piled up at a rate of 2 centimeters every 1,000 years. Over tens of millions of years, this ridiculously simple process built massive geological features. Those spectacular, towering chalk cliffs of the English Channel? Yeah, they are literally mountains built out of the remains of billions of microscopic single-celled organisms that lived 80 to 100 million years ago.
That brings us to Part 3, Sculptors of the Earth.
Prepare yourself for a mind-blowing fact. For 90% of Earth's history, there was absolutely no soil. None. If you walked around 500 million years ago, it would have been a geologist's paradise for sure, but a terrifying alien landscape to you and me. The continents were completely barren, just endless expanses of raw, solid rock baking under the sun.
So, to transform that barren rock into the green continents we know and love today, life had to invent something called bioerosion. This is the physical and chemical breakdown of hard rock surfaces by living organisms. The planet desperately needed some unsung heroes, tiny ecosystem engineers to literally eat and crack the continents apart to create the very first soil. Talk about a tough diet.
Well, enter the lichens.
These incredibly slow-growing symbiotic organisms completely re-engineered the planet. They settled on solid granite and excreted very specific acids that dissolved nutrient-rich minerals like feldspar. Grain by agonizing grain, the lichens cracked the rocks apart. The rock physically crumbled into tiny clay particles, which then washed away in the rain to build the very first layers of soil and push nutrients out to the ocean. And it was only because these tiny engineers broke down the rock that the first early land plants could finally anchor their waxy bodies and rhizoid roots, forever altering our biosphere.
Animals eventually followed plants onto land, but they had a big problem. They had to ally with minerals to survive the crushing force of gravity in the dry air. Arthropods wrap themselves in organic armor, exoskeletons, to prevent dehydration. Tetrapods, our early ancestors, reformed their entire muscular structure, growing dense calcium phosphate bones to literally lift their bodies out of the mud. And as animals moved, they became active sculptors themselves. Termites and millipedes began burrowing, eating the soil and oxygenating the ground. Meanwhile, back in the tidal zones, sea urchins were using a five-tooth structure known as Aristotle's lantern to gently scrape away at sandstone, persistently bio-eroding solid rock over millions of years. Which brings us to the grand engine of our planet. The Earth operates on this eternal rock cycle driven by a triad of forces: plate tectonics, the water cycle, and biological life. They each do about a third of the heavy lifting. This cycle endlessly erodes mountains into dust, washes that nutrient-rich clay into the oceans to feed the plankton, subducts it deep into the Earth's mantle, and then erupts it right back out as new magma. It is exactly why Earth is a living, breathing system, constantly refreshing its nutrients, completely unlike a stagnant dead planet like Mars.
Okay, Part 4, Humanity's Mineral Alliance. Let's fast forward to the savannas of Africa about 7 million years ago. Early hominins stepped out of the trees and started balancing on their hind legs. By doing this, they did something revolutionary. They freed their hands. Picking up a stone became an instinctive extension of the arm, and we began fashioning the very first tools. But the real game changer? Striking rocks together, like flint and pyrite, to create sparks. Domesticating fire using the mineral world was absolutely huge. It allowed our ancestors to cook food, efficiently ingest calories, and feel the explosive growth of the human brain.
Our relationship with stones evolved pretty quickly from just basic survival tools into something profoundly cultural and sacred. The warmth of a fire turned stone caves into safe havens for early storytelling. By 40,000 years ago, those rock walls became canvases for the very first human art, acting like books for future generations to read the landscape. Later on, Neolithic humans dragged and erected 3,000 massive megaliths in Carnac, France. These were symbols of eternity, attempting to match the lifespan of the stones themselves. And eventually, by mining copper, bronze, and iron, metallurgy completely revolutionized human society as we know it.
Which brings us to our final and perhaps most sobering chapter. Part 5. Our new plastic legacy. See, for billions of years, the natural rock cycle operated on this slow, patient rhythm, beautifully balancing the recycling of nutrients. But with the Industrial Revolution, humanity shifted. We went from simply working rocks to aggressively extracting their fossilized energy. We entered an era of human extractivism. We began violently digging up hundreds of millions of years of sequestered dead plant material, like coal and oil, and burning it in a geological blink of an eye. This rapid exploitation is aggressively altering the carbon cycle, shifting the climate, and changing how the very Earth itself reacts. Just think about the sheer scale of what we have built with our extractivist power. 500 billion tons. That is the amount of concrete humans have manufactured in just the last 70 years. To put that massive number into perspective, it equals 1 kilogram of artificial rock for every single square meter of land and sea on planet Earth. We have literally covered the organic, creative ground with slick, smooth, engineered surfaces.
But our industrial footprint doesn't stop at concrete, sadly. During the summer, natural coastal rocks baking in the sun can reach scorching temperatures of over 60 degrees Celsius. When you combine this intense heat with specific, porous rock textures and the mechanical action of ocean waves constantly throwing debris against the shore, something entirely unnatural begins to happen. We have literally invented a new type of rock. It's called plastoglomerate. It was first discovered in Madeira in 2016, and it's now being found worldwide. This is a terrifying hybrid material formed when plastic waste melts in the intense summer heat and permanently glues itself to natural coastal sediments and rocks. The rocks that were once formed from cooling lava are now being shaped by discarded plastic bags and toys. It marks our era as a brutal anomaly,
etched permanently into the geologic record.
There's a quote that says, "The sentences with which Earth speaks to us take millions of years." In our modern world of abundance and instant gratification, we just move too fast. We are too distracted by our slick concrete surfaces. We urgently need to slow ourselves down and respect the almost animistic, ancient life of the mineral world that sustains literally every living thing on this planet.
The Earth is telling us the story of its plight. The dust from the mountains, the cliffs of ancient plankton, the roots splitting the rocks, they're all whispering to us. So as we hastily etch our plastic and concrete legacy into the planet's crust, the real question is, are we finally ready to listen to the stones? Take a moment next time you step outside to deeply ponder your own daily relationship with the ancient living ground beneath your feet. Thanks so much for joining me on this explainer. Keep learning and keep listening to the Earth.